Good evening, ma'am.
Good evening. So we'll start in 5 minutes. Okay, just it. So let's start.
Yes, ma'am.
Okay. So, in this week, sir has taught about the size reduction, particle size, and how the size are reduced like that. So, we'll be doing some basic questions, MCQ, and some problems also. And if you have any question, you can ask. So, the first question is size reduction improves uniformity of mixing. Is it true or false? Size reduction improves uniformity of mixing.
True, ma'am.
Yes, it is true. Next question. In suspension, rate of sedimentation increases if the particles are of small size. In suspension, rate of sedimentation increases if the particles are of small size. Is it true or false?
True.
No, it is false because
True.
suspension happens when the particle size are bigger. Bigger particles are suspended. But if there are fine particles cannot be suspended easily. Okay. So, so here it is in suspension, rate of sedimentation increases if the particles size are of bigger size. Okay. So that is why it is false. Next question. What are the properties to be known for designing a process to select the equipment? What are the properties to be known for designing a process? Like how equipment for to design equipment or to design a process, how for size reduction, how the stepwise process goes. So it's uh, stepwise I will be writing. So if you go through the slides also, you can find it. So first one is the particle size distribution in the field. So we have to first check the size distribution in the feed, that what type of particle, what are their diameters are going to process. Second one is the particle shape, density, elasticity, then friability, then hardness, brittleness. We have to check because depending on these properties of the particles, we have to check the equipment. So we cannot use the same equipment for every kind of particle to be size reduced. So that is why this particle size shape distribution is very important. Third one, particle flowability, cohesiveness, and adhesiveness. That how the particle will behave with other in presence of other kind of particles. So that needs to be checked also. Fourth one is stickiness of the particle. Fifth one is the temperature sensitivity. Then Then sixth one is the corrosivity of the particles. Corrosivity, toxicity, composition of the particle. Then the moisture, oil, fat content of the particle. Then the fibrous morphology. Then reactivity or release of gases. Like in presence of gases, how the particles will behave. We need to check that also. And the last one is the shock sensitivity of the particle. So these are the 10 points to judge which type of particles will go to which particular equipment for the further processing. Next question. Particle disintegration by two rigid forces is called accretion.
Yes, true.
Two rigid forces is For two rigid forces, is it called?
True.
No, it is called compression. When two rigid surfaces are giving pressure, then it is called accretion. Okay. So suppose there is one surface.
Rigid, rigid force, yes, ma'am. Two
Yes.
surfaces and two rigid force. Difference between two surfaces and two rigid force.
Yes. Actually, both are same anyway. But in case of just a minute. So two things are basically same, but if in case of compression, the force should be always come to normal side. Like if this is a particle, the force should be applied normally to the onto the particle. Okay, this is called compression. Like this normal force normal to the particle, and accretion is a method of size reduction by rubbing or scrubbing. Okay, so in any direction you can rub or scrub or give force. You need not to do it always in the normal direction. When we are giving force through normal direction, that is then it is called the compression. Okay, there is a very slight difference between them, but here in this question you can, I think it can be true also. Okay, so proceeding to the next question. Which energy is used for particle disintegration? Which energy is used for particle disintegration? So it is the kinetic energy. So kinetic energy will help kinetic energy of the particle will help to deform it in presence of any force. So for particle disintegration, the energy is used, the kinetic energy. Next question, what is brittle elastic material? What is brittle elastic material? The answer is a material is said to be brittle elastic if the deformation of the product is initially proportional to the applied stress and the fracture occurs suddenly. That is very simple. So that means the the deformation happens is proportional to the stress and suddenly the fracture happens. So this is called the brittle elastic material.
Okay.
Next, what is the critical parameter in fracture mechanism? What is the critical parameter in fracture mechanism?
F is equal to tau square A divided by Y.
Yes. So it is the, so suppose a particle has some crack on it, little bit crack. If we apply force and the size reduction and the crack opens and size reduction occurs as a result of the crack initiation, and finally the crack propagation happens. That means the particle will start breaking from the point of cracking. So this process is this parameter is called the critical parameter of the fracture. Okay. Here F is the critical parameter, tau is the stress applied, A is the crack length, and Y is the Young's modulus.
Okay.
Next, what is the order of magnitude of surface fracture energy for glass? What is the order of magnitude of surface fracture energy for glass? What is the order of magnitude of surface fracture energy? So, this is 1 to 10 for glass. Okay, 1 to 10 for glass. If for 10 to 10 cube, it is the plastics and
Plastic. Yes.
yes, and for 10 cube to 10 to the power 5, it is for metals.
Metals.
Okay. So this is the order of magnitude of surface fracture energy for glass.
And then 10 to 10,000.
That is, I have written just for the parameter, like for the MCQ options. It is not something appropriate. So, next question. The energy requirement for propagating geometrically similar cracks is proportional to what? The energy requirement for propagating geometrically similar cracks.
D square.
No. Yes, this is d square. Sorry. This is d square means the surface area of the particle. So the energy requirement for propagating a geometrically similar crack is proportional to its surface area, the particle surface area, and that is d square. Next, the
dq is the storing energy is too much.
Yes. The cube is the storing energy. Next, the
Then
energy.
difference between
Yes.
storing energy, or your critical energy and linearly.
Difference between these two. Okay. So, so a particle can, how much energy it can store before cracking, how much energy it can possess. This is defined by the volume of the particle. That is why it is the
Okay.
dq.
Oh,
And if some crack comes up and the energy available per unit crack area increases linearly. So if some crack comes, so if this has some kind of energy, some amount of energy, and if the crack increases, the energy availability also increases linearly. So that is why it is said that it will linearly increase with the particle diameter. So how much diameter one particle has, it will depend on that. So if it is a smaller particle, small energy availability will be there, and if it is larger particles, large availability will be there. So that is why it is dependent on particle size, and total energy storing capacity is dependent on the volume of the particle. Okay. Next, now this is very easy. The energy available per unit crack area increases linearly with particle size, and it is so true. Next question. Which equipment is used for compression of particles? Which equipment is used for the compression of particles? Which equipment is used for compression of particles? Can you say? So the answer is gyratory crusher here. So any kind of crushers are used for compression of particles. Okay.
okay.
Next, what types of mills are used to reduce the particle size to less than 6 millimeter? What kind of mills are used to reduce the particle size less than 6 millimeter?
Grinder.
Yes, it is the grinder, or you can call it ultrafine grinder. Ultrafine grinders, and under this it comes hammer mills with internal classification. Then comes fluid energy mills, and lastly the agitated mills. So it handles the very fine particles. This kind of grinders or mills make the particle very fine. Next question. Knife is used for particular shape and size reduction. Knife is used for particular shape and size reduction. Is it true or false?
True.
Yes. The answer is true. Next, what is the feed and product size in crusher? What is the feed and product size in crusher?
Fif- 1500 to 40 millimeter.
Yes. So feed size should be 1500 to 40 millimeter. That means it is a bigger size particle. Crusher handle.
Product size, ma'am.
Yes.
Okay.
Crusher handles bigger size particles, so it makes bigger particle into smaller size. So 1500 to 40 millimeter is the feed size and product size is the 50 to 5 millimeter. Next, intermediate size particles are crushed in jaw crusher. Intermediate size particles are crushed in jaw crusher. Is it true or false? Intermediate size particles are crushed in. Yes, it is false.
False. Intermediate is a grinder.
Yes, intermediate size particles are crushed in grinder. Next, what are the types of ultrafine grinders? So, ultrafine grinders can be divided
Type
into two bases. Two bases. So, first one is
hammer mill.
yes, but among them some comes under the dry basis and some comes under the wet basis. Okay. So dry basis means
Yes.
in the dry basis comes the hammer mills. Here only the dry solid particles are handled. Hammer mills. And in the wet basis comes the fluid energy, because in these cases fluid is also there with the particles. So that is why it has two bases. Fluid energy mills, jet mills, colloid mills, etc. Next, what is the efficiency of a ball mill? What is the efficiency of a ball mill?
One to 10, 5 to 10.
Yes, the
5
answer
to
is
10
5 to 10% is the efficiency of the ball mill. Next, jaw crusher has small crushing ratio. Is it true or false? Jaw crusher has small crushing ratio.
False.
No, it is true, because it is one of the disadvantages of jaw crusher. If you see the disadvantages list of the jaw crusher, you can find that it has lower productivity, high power consumption, bigger vibration, uneven particle size, and last one is the small crushing ratio. Okay, so it is true. Next, now I show the different type of crushers with the videos. So how this crusher will work, you will see.
Maybelline New York Superstay Matte.
So this is will show the jaw crusher working principle. So you can see bigger size of particles are coming through one side, and between the two reverse fixed jaw, one is a fixed jaw and another one is the reversible jaw. So depending on between these two jaw and one flywheel, these particles are getting crushed into smaller sizes. So everything is pointed out here. So I hope you can understand it. Next is this one is the jaw crusher. So two jaws are there. That is why it is called jaw crusher. Next one is the gyratory crusher. So it has some kind of concave surface and a conical head. You can see this is the shell with liner, and from top feed is coming, and this is some kind of conical shape is there. So that is why it is called the gyratory crusher. The principle is same, because in jaw crusher also the bigger particles are getting crushed. Here also bigger particles are getting crushed. This one is the cone crusher. So you can see this, there's a cone kind of shape, movable cone lined plate, and one is the fixed cone lined plate, and from top feeding material is coming, and from with the through the help of movable cone lined plate, the particles are getting crushed, and it is collected in the bottom discharge. So here no jaws are there, so that is why it is not called jaw crusher, rather it is called the cone crusher. Next is the smooth roll crusher. Smooth roll crusher. So here you can see that the two rollers are rotated in the opposite direction, and with the help of friction and gravity, the bigger particles are getting crushed inside the two rolls, and smaller particles are getting created. So next one is the toothed roll crusher. The last one is this one is the smooth roll crusher, because you can see the rolls are very smooth, and here you will see that there is some kind of tooths are in the rolls of the machine. So that is why it is called tooth. Some barriers are there. Alternative, periodically some barriers are there. You can see this. These are the tooths of the roll. That is why it is called tooth crusher. The principle is same, but in case of ball mill, in case of roll mill, plain roll mill, there is no this kind of periodic barrier or periodic gravel. So that is why it is called tooth crusher and stone crusher. Now, next question. What is the ratio of feed to product size in toothed roll crusher? What is the ratio of feed to product size in the tooth roll crusher?
6:1.
Yes, this is the 6:1. Now comes the different type of mills. So mills will handle the intermediate size of particles. So first there is crusher which crushes the bigger particles, comparatively bigger particles, and then it comes to the mills. Mills will handle the intermediate size of particles. So first one is the ball mill. So in the ball mill, you can see this is the everything is there. This is a bucket elevator, raw material, xylo. This is a complete factory of ball mill. This is the now we'll see later one by one. So from here feed is given and it will pass through the bucket elevator to the xylo. And now it will come to this ball mill where there are balls inside the mill. Okay, so because of the attrition, this is called attrition. So because of this attrition of the ball on the particles will get crashed and generate smaller particles. Now you can see these the fine particles are generated. Okay, now these are the after processing of the ball mill factory. So that is not important. Basically, the important part is this ball mill applies the principle of attrition. Okay.
Okay.
So this is the ball mill. Rod mill is also similar, but in case of rod mill, you will see the rod. There are rods in place of instead of balls. So here in the ball mill, inside the chamber, main chamber, there are balls are there. But in case of rod mill, you will see there are rods are there. So same way the feeds are coming, which is a mixture of different size of particles, and it will go through the main portion of the main chamber of the factory, and this will produce fine particles, and inside the chamber there is balls, there is rods instead of balls. This one is the hammer mill. So something is rotating and it is getting hammered. The particles are getting hammered because of this rotation each time, and they are creating smaller particles. So now see. Here some kind of bars are there. You can see the bars. in the rotating equipment. So this will hammer the particles and they will produce the smaller particles. Okay, so you can see how small the particles can be produced through the help of hammer mill. So this is a whole machine of the hammer mill. So how a hammer mill works, it will show here. So these are the motors of the different motors portion of the hammer mill. The gears are there, and if the complete machine is there. Next, this is also a hammer mill. This is a basic structure. So this is not smooth rotating machine. This is some bars are there, and it will help in creating smaller particles. It is the basic structure of the hammer. Okay, so now last two are there. So this one is the attrition mill. So this one is the attrition mill. So in case of attrition mill, the grains are rubbed between the grooved flat faces of rotating circular roughened discs. So here you can see the straight. So always you can see the attrition mill is always shaking. The whole portion of the mill where the feed will come, it is continuously shaking. So these are the motors which is making this kind of vibration to the machine, and they are set up on some spring so that it will not affect the ground. So in this place, the main feed will come. So you see that the feed will come from the top, and because of the continuous attrition inside, it will create the smaller particles. You see that how the section of the equipment is moving and creating attrition. So these are different types of attrition mill. So ball mill also one kind of attrition mill. Last one is the fluid energy mill. Fluid energy mill. So the particles along with the fluids will be absorbed from the bottom and it will passing through this portion, and now you see here it's some kind of separator. The heavy particles are following down. You can see this. The discharge valve is there. The heavy particles are falling down, and the rest of the smaller particles or fluid will go through the other chamber, and that is how they are separated.
Okay.
So these are the different types of crushers and mills you can study about. Next, what is the speed of the ball mill with respect to the critical speed? What is the speed of the ball mill with respect to critical speed? So
50 to 70.
yes, the answer is 50 to 75% of the with respect to the critical speed, the ball mill will run. Next question. The product size of fine grinding material is the product size of fine grinding material is
1 to 10 micrometer.
that is called ultra fine. For fine, it is only fine I am saying, so it is 100 micrometer. Okay. Next, energy requirement is highest for ball mill out of jaw crusher, rod mill, ball mill, and fluid energy mill. Which one is true? Is it true or false? Among jaw crusher, rod mill, ball mill, and fluid energy, which equipment needs highest energy?
I don't know.
So the answer is false because fluid energy mill will require the highest energy. Fluid energy mill will require the highest energy. Among these four, I am comparing. Maybe there are some other equipment also which needs more energy than the fluid energy mill. But among these four, fluid energy would be the right answer. Okay. So now we'll do some question or description or whatever the equations we have used, the derivation we will do. Or if you have any question, you can ask from the assignment or in.
Okay. Oops. Assignment second.
Hmm.
Which mechanism is utilized when particle consists by a single rigid force? This my answer is impact. That is true.
Which mechanism is utilized when particle concoctions by a single rigid force? Yes, it is impact.
Second is what are the geometrical factor affecting size reduction? My answer is shape and size.
Yes, it is shape and size. Then there are maths,
Critical.
so you have to calculate.
Yes.
So you are able to do the calculation of all the sums, right? So I think every equation is already given in the sir notes. If you go through the equation, you will find everything is given. We have to calculate the rest of it. So I'll do some problems on that, different problems.
Ma'am, please.
Hmm.
Question number 6 and 7.
So it is the what group of angle is given. What is the maximum pitch size for the crusher? Okay. So before that, I will explain what is this roll and ball crusher. Then we'll come. So in case of if I'm doing a derivation, that how is it coming, you will then understand. Okay. So in case of roll crusher, there are two rolls, right? There are two rolls, and in between the particle is coming. or maybe let me draw it as right. So in case of roll crushers, what happens that these are the two rolls, and this is our particles, right? These are particles. Suppose it has radius r1. Both the balls are of similar size. Okay, this is of radius r2, and this is the distance between the two rolls, which is defined by d3. Okay, so its radius is r1. Both of them have same radius. The smaller one is our feed particle, that is r2, and the distance between the two particles is d3. Now if we imagine a line between this connecting line, and we are seeing that this feed particle is in some angle with the rod wheel, right? With the roll, the crushing rolls, it has creates some angle. What is this angle? This is AN, which is our angle of nip. Okay. Now what will happen at this point? When there are two forces, always there are two forces. So in this point, this is the tangential force. You know what is the tangential force is, and in the normal direction, that is the normal force, right? So two kinds of force are acting on this contact point, where the crusher rolls and the feed particles mix, like touches each other, right? Are you getting?
Yes.
Yes. Now, so if it is the angle, then its half angle, we can consider it half, AN by 2. Okay. And similarly, if we draw a triangle between them, so if it is a triangle, so you will see that finally this angle also come as N by 2. Okay, this is just the mathematics, geometry. Okay, this is just a geometry. So you will see that this angle will also come at N by 2. Now, the vertical component of this tangential force, right? So tangential force acts at this point, and its vertical direction is this one, right? So you know from early age that suppose this is some kind of triangle and it is 90 degree, and it has theta, and it is 90 minus theta. So this distance, suppose it is A, B, C. So what is called AB is called the cos theta, right? So we will see that AB by AC, the base by hypotenuse, is the angle cos theta we call, right? You remember? Are you listening? Are you getting anything?
Yes.
Yes, so this is called cos theta, right? And when we write BC by AC, it is called the sin theta, right? So in case of FT, what will happen? The its vertical component is the cos theta one. So we'll see the vertical component. We'll write that vertical component of tangential force is, suppose its name is FTV, and it is equals to FT cos theta or cos an by 2. Here it is not theta, here it is an by 2. So here how am I calculating? It is the tangential force and it is vertical components will act in direction, and this is nothing but the base of this angle, right? This is nothing but the base of this angle, and this angle has a angle of an by 2. That is why it is coming cos an by 2, right? And second one, we will calculate the vertical component of normal force. This one is the previous one is a normal force. This one is the previous one is a tangential force. This one is the normal force. So here the component name will be FNV. So now now normal force will walk in this side, in this direction. So its vertical component will be this one, right? This one. So this one is the vertical component of the normal force, right? So, and from the triangle, what we understand? We understand that it is, so I am, if you get confused, so I am again drawing the just triangle here similarly. So here, this is our triangle. It is n by 2 I am talking about. This is 90 degree, okay? So in this direction, Ft was working, in this direction, Fn was working. So in case of tangential force Ft, the vertical component will be this. That means, and it has the angle n by 2. So that is why I am taking as Ft cos n by 2. And in case of normal force, the perpendicular one direction is the vertical component of the normal force, and it is similar as BC. So we are getting it as Fn sin theta. So now what is the expression of normal force? It is Fn sin an by 2. You got it?
Yes.
Yes. Now, so what will happen when this FTV, that is vertical component of this tangential force, will be greater than vertical component of normal force, then only this particle of R2 radius will get crushed. So this is our theory, that we want to crush the material, right? So when it will crush? When the tangential force, the vertical component of the tangential force will be greater than the vertical component of the normal force. And now, if you write the expression, what will come? So FTV is Ft cos an by 2 greater than Fn sin an greater by 2. Right? So I am going to the next page. So what will come? So here we have written the expression. So now we will do the simple mathematics here. So what I have written, if T cos an by 2 will be greater than if n sin an by 2, right? So if we take everything in the left side, Ft by Fn, sorry, is greater than sin an by 2 divided by cos an by 2, right? So sin theta by cos theta, we know that it is
Tan
tan theta. Yes. And ft by an, we are representing it as mu. That is nothing but the coefficient of friction. Coefficient of friction is greater than tan an by 2. Now what will happen? This means that if it is greater than mu, if the tan an2 value is greater than mu, then it will get crashed. And this one is the critical angle. This is called the critical angle of knee. Okay. Now coming to the picture again. So till now we have considered the small triangle. Now we have to consider the bigger angle. If we consider the bigger triangle, okay, suppose it is A, it is C, it is C, and it is D, right? So what will happen? Again, I am showing. So what I have seen that it is A, B, and this one is C, right? And this C. And this angle is the AN by 2. And if we consider now this, if we consider this, the cos, then what will happen to the cos AN by 2? Cos AN by 2 expression will be AD by AC, right? AD by AC. And now we'll write the distance. So what is AD? You can see that AD covers the radius of the roll, right? It covers the radius of the roll crusher. So that is R1 I have said, plus it goes half of the distance of D3, right? Where is this point? Till the roll crusher, it is from this A point to this point. I hope you are understanding which point I am talking about. It is this distance is R1, and from this point to the middle of this to the D point, that is the half of the distance D3. Okay. So what will happen? So this is R1. So AD is R1 plus half of D3. Suppose half of D3, we can write it as R3 also. Okay. So now as it is, let me write. It is R1 plus D3 by 2. And what is AC from this picture? AC is also the, from this point to this point, the distance is R1, right? And from this point to this point, so my drawing is not that good, that is why it is happening. From this point is this point till the AC, it is the radius of the feed. Okay, it is the radius of the feet, which we have already defined by R2. So R1 plus R3 divided by R1 plus R2. So you have to remember that R1 is the radius of the roll crusher. Okay. R2 is the radius of the feed. And R3 is the half of the distance between two rolls. Okay, so this description we have to remember, otherwise you cannot do the problem. You will confuse it that which one you have to calculate. Okay, so remember the expression and its what is the meaning of it. And do you understand the derivation?
Yes, sir.
Okay, so now going back to the question. So here are just the namings are different. The parameters are written different, but the meaning is same. Okay, so
Yes.
don't get confused with that. So what is said in the secret said, a select line manufacturer uses a roll crusher to crush limestone. The crushing rolls have a roll of 150 centimeter and a diameter by width of 50 centimeter. The crushing rolls have a roll of 150 centimeter and a diameter by width of 50 centimeter.
Yes. The clearance between the rolls is 1 centimeter. मतलब D is 1 centimeter.
Which one? D is 1
And
centimeter. Yes, D is 1 centimeter. The clearance between the rolls is 1 centimeter.
okay.
Okay. Then, just a minute. Yes. So also you can see that clear the angle of what is the feet size. So the thing is that D, what is we have called D here in this diagram, it's also you can remember it as the not only the clearance between the particles, not only the clearance between the two rolls, also it is the diameter of the product. Okay, so that will be much more easier to remember that D3, what we have written D3 is the diameter of the product. That means R3 is the radius of the product. So I can write also this is the radius of the product. So that will be easier for you to remember. So what is R1 in both denominator and numerator? There is R1. So R1 is the radius of the roll crusher. R3 is the radius of the product and R2 is the radius of the feed, right? And this is written that the clearance between the rolls is 1 centimeter. That means the feed is the product size is 1 centimeter diameter. Okay. Now it is called that the rolls run at 100 RPM. The angle of knee is 30 degree. What is the maximum feed size for the crusher in centimeter? The angle of NIP establishes the maximum particle size according to the formula is already given. So here the rolls run at 100 RPM is not important, right? So you have to choose that many values are there. So you have to choose what is important to you. It is said that RR in both cases you see RR. In our case it is R1, right? It is R1. So it is nothing but the roll diameter or roll radius. Sorry. It is nothing but the roll radius. So we'll see the radius of the roll is given as 50 centimeter.
Okay.
Okay. It is 50 centimeter. Then the clearance is 1 centimeter. That means it will be the RP is the product size. It will be 0.5 centimeter. Theta is given as 30 degree and you have to calculate the feet size, that is A. Okay, that is A. So let us calculate. I don't know. I'm thinking it right or not. Let's check. So what is? It is cos theta by 2, right? So it is cos 15 degree, right? Our theta is 30 degrees, so it will be cos 15 degree, and
Okay.
r is the 50 centimeter. That means we are calculating the radius here, so we have to take 25 plus a, that means in case of us it is r2, sorry, r2, and here again it is 25 plus what is the diameter of the product? It is given 1 centimeter is the diameter, so we are taking 0.5 centimeter as the product. So let's calculate. You also calculate, see whether it is coming or not.
Okay, ma'am, I am calculate. Please next question.
Okay. So it will, I think it is something, I think I am missing something, or let me check, because it is coming negative, then it will not happen. The crushing rolls have a roll of 150 centimeters and a diameter by width of 50 centimeters. What is 150? 150 and 75. 50. So how much is it coming?
Yes, ma'am.
Did you calculate how much is it coming?
It represent not scientific calculator, but I am calculate.
Okay. Oh, I think I have missed writing something. Just a minute. R1 is 25. R3 is the product side. Acha, R3 is the product side. Okay. Yeah. So I have written mistakenly here. So our formula was this one, right? Here it is R3 and here it is R2. So you have not said it. You should correct me now. So it is formula is what? Cos theta by 2 R1 plus R3 by R1 plus R2. So it is cos 15 degree equals to R1 is 25 centimeter, R3 is the radius of the product, which is 0.5. Next, again this is 25 plus feet size, that is R2. So now calculate it. So we can find divided by 26 and 7 25 equals 50. Is it there? 2.79. Yes. So here also I have done one mistake, that is the crushing rolls have a roll of 150 centimeter and the diameter by width of 50 centimeter. So that doesn't mean that diameter is 50 centimeter. It is said that diameter by width. Okay, so the actually the diameter is 150 centimeter. Okay, so don't you might confuse with this language, but you check. Okay. So our diameter is 150 centimeter, not the 50 centimeter. Then only we can proceed with the sum. So if it is 150 centimeter, so now it will come at 75, right? So it will be 75 centimeter. So what I have written as 25 is wrong. Okay, don't do this. You understood where the problem is? Yes.
Yes, ma'am.
So diameter is roll diameter is 150 centimeter. So radius will be 75 centimeter. The product size is given 1 centimeter. That means the radius will be 0.5 centimeter. So R2 will be coming as 3.15 centimeter. And it in the question it has asked for the diameter of the feet. So it will be 3.15 into 2, which is 6.314 centimeter, and which is I think almost near to this value of D. 6.47 it is given, and we have got 6.31. So I think it will be the correct answer. Still you check. Okay.
Thank you.
Okay. Yeah. Anything else?
The next question, the rotational speed.
Okay. The rotational speed you would recommend for a ball mill that is 1000 millimeter. So it is also for that also you need to know the basics of the ball mill. So let me do some calculation derivation here, and I will tell you.
Okay, no, thank you.
So for the ball mill, what happens that in the ball mill you can see that there is big ball here, and inside this is your feed particle. Okay, so this ball is continuously rotating, and along with this feed particle will also rotate, right? So this bigger particle has a radius of not particle. This is the ball diameter. Ball diameter is r, and feed particle diameter is small r. right? Now what will happen? How this will move inside the ball? So we know that ball has a gravitational energy which is nothing but mg, right? And this is the ball and it is in angle with the center of the ball. The feed particle is in angle with the center of the ball, which is theta. Okay. Now the ball will rotate in a speed and it will gain some speed, which is the centrifugal force. So for the speed particle, the centrifugal force expression is mv square by r minus r. So it has m is the mass of the feed particle, v square is how much speed it is rotating, and this is the difference between the two diameters, right? This is the centrifugal force. And next one, and another force, what will happen? This centrifugal force will try to, it is applying in this direction, it is working in this direction, and this gravitational force is working in opposite direction. So when this gravitational force and centrifugal force will be similar, centrifugal force equals to gravitational force. Okay, so these two force, when these two force will be equal, the ball will lose contact and will fall down onto the particles. Okay, so this two has to be equal to fall down this feed particle. Okay, so now what we are doing the expression simply. So here centrifugal force is mv square by r minus r, and gravitational force is mg. Not only mg, because it has some angle with this ball center, so it is along the theta, so it will be mg cos theta. Okay, so what is the expression of cos theta? It is cos theta will be will be cancelled out. It will be v square by r minus small r into g. Okay, and now what is this v in terms of rotational speed? So v in terms of rotational speed will be 2 pi n and r minus r. You know 2 pi r is the radius of the ball, and n is the rotation. N is the number of rotation. Okay. So if you now put this value of v in this equation, what will happen? So we have to calculate v square. So v square is 4 pi square n square r minus r square, right?
Okay.
Right? Yeah. Now next we'll put this value in the cos theta. So what will come? So if we put the expression of v square in the cos theta, what will happen? So cos theta will be v square is 4 pi square n square r minus r square, and what was in the denominator, that is r minus r into g. R minus r into g. So this one r minus r will cancel out. So what is remaining? 4 pi square n square r minus r divided by g. Okay. So now At critical speed, at critical speed, we always consider that theta will be 0 degree. Okay, and n will be represented as nc because it is the rotation. N is nothing but the rotation of speed. So at critical speed, n is termed as nc. So what is cos theta? Now at critical speed, cos theta is cos 0 degree. So you know the value of cos 0 degree is 1, and it will be 4 pi square nc square r minus r by g. And now if we want to calculate nc square or critical speed, it will come like this. Nc square equals to 4 g divided by 4 pi square r minus r. And what will be nc equals to 1 by 2 pi root under g by r minus r. So this is the expression of the critical speed in a ball mill. So now the question is given depending on this equation only, that the rotational speed RPM you would recommend for a ball mill that is 1000 millimeter in diameter charged with 70 millimeter balls, right? So everything is given. It is very easy. So here the ball mill radius is given as 1000 and speed particle radius is given as 70 millimeter. Okay. So these are all given as diameter. So we have to calculate it first the radius and then we will change. Now, what is the speed? So NC will be 1 by 2 pi root under G by 1000 millimeter diameter is a ball diameter. So it will be 500. Its radius will be 500 and the particle's diameter is 70 millimeters. So it will be 35. So how much is it coming? Minus 35. 9.81 divided by rotational speed, rotation per minute, they said, right? So answer is 0.023. It is coming in rotation per second. And now they have asked for the rotation per minute. So rotation per minute means, so we want to change it to rotation per second, rotation per minute. So it is, we have to multiply it with just a minute. Okay, so the calculation you have to do with the millimeter, not millimeter, rather meter. Okay, so I have written it in millimeter. So that is why the answer is not coming. Okay, so in meter, what will happen? 500 millimeter means 0.5 meter and 35 millimeter means 0.035 meter. Okay, now you do the calculation, you will get. Because when the derivation is done, it is mentioned that the particle size are in radius meter. So that is why if we consider it in meter, that is how this whole derivation, the whole expression is coming. So every time we have to use this meter. Okay. So 0.5 minus 0.035 and 9.81 divided by this is 0.73. Yes. So it is coming as 0.73 rotation per second, because in the expression also, in this also, NC is considered as rotation per second. So the answer is coming in rotation per second. But in the question, it is asked that you have to do it in rotation per minute. Yes. So per minute means we have to multiply it with 60. So from that means 1 minute equals to 60 seconds, right? So we have to multiply it with 60. So 0.73 into 60 equals to 43.88 RPM. 43 to 8.88 43. Yes. So you can use this answer, 43.88 RPM. Now this is the thing, and also one thing you have noticed that in the notes, sir has taught that the ball mill speed is the 50 to 70% of the critical speed, right? It is not the actual ball mill speed. It is the critical speed we have calculated, right? So in the, if you remember in the one question I also given that I also have given that what is the critical speed of the ball mill. So the answer was 50 to 75%, right? So you have to calculate with that. So if this is 50%, so what is the 50% value? So 43.88 RPM into 50%. The value is 21.94 RPM, and if it is 75%, so it will be multiplied by 0.75. 0.75, it will be coming as 32.91 RPM. So if you see in the question also, they have given some range in the answer. So what range one should move? In what range the ball mill is functioning? So the answer will be this B. Okay. 21 to 32. So and how it is calculated, you remember, right? So the whole process is for the critical speed calculation, but the actual speed of the ball mill is the 50 to 75%. So that is why we have to do this sum later, do this problem later. Okay, we have to do this calculation, otherwise it will not get the right answer. Okay, this is the little things you have to remember.
Okay.
Any other? Did you get the 6 and 7? How I am calculating?
Yes, ma'am. Yes.
If you have any questions, still you can ask.
Okay, ma'am. Thank you.
Okay.
Okay, ma'am. But ma'am, I am what generally question. I am two course online NPTEL, but doubt clear is same time 3 to 5 p.m. and second course is 3 to 5 p.m. So I am only one attending course.
So I don't know, because this is the time given from the NPTEL, so I have to do this in time. You can go through the videos ना. I have uploading ना. They are sharing.
तो मैम जैसे मैं अटेंड नहीं सेकंड वाले कोर्स का अटेंड नहीं करता तो उसका कोई प्रॉब्लम तो नहीं है?
सेकंड वाले कोर्स मतलब कौन सा कोर्स?
मैम मैंने एक IIT रोगी से भी लिया है, डॉक्टर पी मंडल, बेसिक इन्वायरमेंटल एंड अबेटमेंट का। तो उसका भी टाइमिंग सेम था, 3 to 5 PM।
Okay. So you have to manage, like one day you can join here, because anyway both of us are uploading in the YouTube, so you can later also check and put your question. So that doesn't mean you have to.
अटेंडेंस का कोई वो तो नहीं रहता कि आपने ज्वाइन किया कि नहीं?
This is not about any attendance. This is just a class. This is not your actual class you are doing in school. There is no.
Okay, thank
So
you.
this is the for the, yeah, sure. You check the YouTube videos. I will show.
Okay, thank you.
Yes, yes. So now we have done some problems on the critical speed and ball mill and ball mill and roll crusher. So next we'll proceed to do some problems on the size reduction laws, that is Bond's law, Kick's law, and the Rittinger's law. So let me do. So it is in Rittinger's law. In Rittinger's law, what is the formula? The work required for size reduction is proportional to the new surface area created. Okay. What is this new surface area? New surface area means a larger particle is getting crushed and created smaller particles. That means it is creating new surface area, right? When something is getting reduced in size, its surface area increases. It is creating new surface area. Okay. So it is, so work required is proportional to the new surface area created. So it is proportional to the new surface area created. You may find the notation of the notation I am using and what sir has used is different, but the basic fundamental is same. The notation is different only, nothing else. So this is, so ASSB is the new surface created, new surface, and this is the old surface, and we are taking the difference of them, and that is proportional to the work required for Rittinger's law. So how it is coming? So how this expression of surface area will come, I will tell. So first, in a sample, if in a sample of uniform particle of diameter dp, the total volume of particle, so suppose there is a particle of diameter dp and its volume is m, its mass is m, sorry, and its density is rho p. So the volume of this particle is Vs, and Vs is equals to m by rho p. Okay. So total volume of this particle. Okay. So there are many particles which have similar diameter, that is dp, and whose total mass is m and whose density are rho p. So its total volume is total mass by total density, that is Vs. If the individual volume of particle is Vp, then how many number of particles are present? So how we'll calculate? It will be total volume of the particle divided by the single volume of this particle. So what is Vs? Vs is m by rho p into Vp. Okay. Now the total surface area, if you have to calculate, it will be n into Sp, and Sp is the individual surface area. So now you know the expression of n. What is it? So it will be m Sp rho p by Vp, right? It is the expression of total surface area, that is m Sp by rho p into Vp. Now what we know from sphericity, in the last class we have learned that 6 by dp divided by Sp by Vp. So from Sp by Vp, what we can calculate? It is nothing but 6 by dp by phi s, right? So if we input this value, what will come? Surface area will be m 6m by rho p, as it is dp and phi s. This is the expression of the total surface area of the particles. Now if we calculate the specific surface area. Specific surface area. Suppose it is AW. So how we will calculate the specific surface area? Means we have to divide each of the surface area to the total mass. Okay, so it will be m1 rho p dp1 phi s divided by m. That means there are different size of particles, right? Suppose this size of particles are this much. Intermediate size of particles are this much. And now these are the small particles, and this is the combination of all the particles. So how we calculate the specific surface area for each type of particles? So now this is we'll calculate. So suppose m1 is the mass of the bigger particles, dp1 is the radius of the bigger particles, and we have to divide this combination with the total mass of the system. And rho p will be same because density of the particle and sphericity of the all the particles are same because we are using the same kind of particle. So similarly second one will be 6m2 rho p dp2 pi s divided by m2. And similarly, if there are m type of particles, the equation will be continuous of that. Now we will now separate. Now this m1 and by m. Leaving rest of the things, we will consider m1 by m. So it will be 6 rho p dp1 pi s. m1 by m, we know that m1 by m is nothing but the mass fraction of that particular shape of particle in the mixture, right? So it is m by m1, m1 by m will be x1. Similarly, rho p dp2 pi s will be x2. And if it has m number of particles, it will be 6 rho p dpm phi s by into xm, right? Now, how will you write it in summation? So in summation, we will write the total specific area of individual particle. You can see that 6 by rho p and phi s is nothing but the constant. So we will take it out 6 by rho p phi s and we will do summation here. Summation of this x1 by dp. So it is xi by dpi summation I equals to 1 to n. So this is the formula of specific surface area. Now, if in the Rittinger's law case, and we also know that the mass fraction of all the particles is always 1, right? So, the specific area also can be written as this. So 6 rho p phi s xi summation of xi will be 1. So it will be 1 by dpb, that is the average size of particles. So now coming back to the Rittinger's law, you have seen that ASSB is the new surface, that means the product surface, and ASSA, that is the old surface specific area. So with that we will write, so W varies as ASSP or ASS feet. New surface area is written, right? So ASSP will be 6 by phi s rho p and 1 by dpp, and for feet case it will be 6 by phi s rho p, it will be for feed, right? So coming back to Rittinger's law, it will be W equals to something K ASSP minus ASSF. This is nothing but the K into 6 by phi s into rho p into 1 by dpp minus 1 by dpf. And together we can write it as Kr 1 by dp P product minus 1 by speed. This is the Rittinger's law. Next, is the Kick's law, right? So what is Kick's law? Kick's law is the work required for crushing is constant for a given mass of material for a constant reduction ratio irrespective of their initial size. So irrespective of their initial size, the crushing is constant, the work required. So it will be defined as work required by, this is constant, it will be depend on speed particle ratio to product particle ratio. This is the Kick's law. Next comes the Bond's law. And in Bond's law, the work required for crushing is directly proportional to the square root of surface area to volume ratio. Right, so it is root over SP by VP. So similarly from phi S we know 6 by dP equals to SP by VP. It is nothing but six dP phi S, and so it will be what is equals to, suppose K is a constant, proportional constant, it will be 6 by dP phi S, and W equals to 6K square by phi S, and it will be 1 by root over dP. And this root over 6K square by phi S is nothing but the Bond constant. So finally the expression comes as (0.3162 work index 1 by root over dPb minus 1 by root over dP, P is a product, and dPf. Okay. These are the three laws of size reduction. Now we'll do a problem. So let's first write the question. A crusher and a grinder connected to the same power drive of 2700 kg per hour of limestone. It first passes through crusher, then through grinder in succession. Screen analysis of feed product from the crusher and grinder indicate surface area of 2.9103 and 865 meter square per kg respectively. Okay. Then calculate the power required by the drive to run the assembly. Efficiency of crusher is 20% and grinder is 25%, and it is given Rittinger's number is 77.4 meter square per kg. Now we have to calculate. So we know that in Rittinger's law, W is the work done. This is nothing but the power required, that is power divided by K. Its flow rate or mass flow rate is Rittinger's constant into new surface area created. Okay. So now in the question it is given as Rittinger's number, but we have to calculate Rittinger's constant. So this kilojoule. So Rittinger's constant Kr is 1 by Rittinger's number, which is given in the question, which is 1 by 77.4 kilojoule per meter square. If you want to convert into joules, it will be 1000 by 77.4 joule per meter square. It is the Rittinger's constant. Now using the Rittinger's law for the crusher first, right? So crusher is operating first. What will happen? It is required, the power is, so we know now the value of Kr. Kr is 1000 by 77.4 and new surface area is created 103 and feet size is created, feet size was 2.9. And in the question you will see that is given, the mass flow rate is given at 2700 kg per hour. So now we'll calculate the total power required. It will be 27 by 3600 because we are calculating kg per second, multiplied by 1000 into 77.4 in joule per meter square and into 103 minus 2.9. It will come at, you calculate, it will come at 969.96 watt. Now it is said that crusher efficiency is 20%. So total power required for crusher is 969.96 divided by 0.2, that is 4849.8 watt. Okay, that is nothing but 4.8 kilowatt. This is for crusher. Similarly, we will do it for grinder. So in the grinder also, power required will be, M is 2700 by 3600. The Rittinger's number is 1000 by 77.4 and now the new area is 365 minus 103, right? The value was 365, right? 865, sorry. It will be 865. So now the value will come because in the case of grinder, the product is of 865 kg meter square per kg and feed is of 103 because it is previously it is coming from the before the grinder, it is already crushed in the crusher. That is why the product size of the crusher is the feed size of the grinder. So how much is it? It is 7383.72 watt. Now its efficiency is 25%. So actual power required is 0.25, it is nothing but 29534.8 watt, that is 29.5 kilowatts. So total power required combining the assembly, that is crusher and grinder, is 4.8 plus 29.5 equals to 34.3 kilowatt. So this is the answer. Okay. So this is the problem using, this is one of the problem using Rittinger's law. Similarly, you can use the Hicks law also and the Bond's law also. Okay. So let's do a problem on Bond's law. What is it is asked that it is said 270 kilowatt of power is required to crush 150 ton per hour of material. Okay. If 80% of feed passes through a 50 millimeter screen and 80% of product passes through 3 millimeter screen, calculate the work index of the material. And second part of this question is, what will be the power required for the same feed at 150 ton per hour to be crushed to a product such that 80% is to pass through a 1.5 millimeter screen. Okay. So it has two parts. The question has two parts. So in the first part, everything is given. So as per the Bond's law, the expression is P by M, 0.3162 work index, 1 by D of product minus 1 by root under D of feed. Right? So initially it is written that P is in 270 kilowatt per hour, kilowatt, not per hour. M is 150 ton per hour equals to 0.3162 work index, and it is in the question, it is the product size is 3 millimeter that means 3, and feet size is 50. So after calculating, it is coming as, work index is coming as 13.06 kilowatt hour per ton. Okay. In the second part of the question, it is said that same equation we are using, same instrument we are using, same feed rate is using, that is 150 ton per hour, and now the work index we know, that is same instrument, means that same work index will be used, and now the product size is different, that is 1.5 millimeter, and the feet size is same, that is 50. So what will be the power required? And it is coming as 418.16 kilowatt. So this is the second answer, and this is the first answer. Similarly, you can do problems on Fick's law also. So that's it. Okay, so I hope you have understood today's class. Have you understood today's class, and we will go through the equations also, and in the assignment also same equations are already given. You have to just find what the exact value to be used in exact places, because that is little bit confusing. Otherwise everything easy. I have done all type of problems in the session, and if you go through the lectures you will understand it. So thank you for joining in, and till next week, goodbye.